Assalamualaikum and hi, I'm Naziha binti Zainuddin. So today I'm gonna talk about activity 1, which is basic operation. So firstly, we need to construct this circuit in multi-sim. But in first activity, we don't have to connect switch 2 in this circuit. Therefore, the circuit will be like this. Then we have to make sure that switch 1 and switch SG in open condition. Therefore, we will get the lamp is in off condition because there are no current can through this circuit. After that, we close switch 1 but SG is remain open and we will get the LED is still closed. It is because the gate leg of the SCR is not triggered. But if we close both of the switch, the lamp will on because the gate leg of SCR have been triggered. Therefore, the current can through this circuit. Then, if we open back this SG switch, the lamp will still open because the SCR have reached on state, which is it have been triggered, so it will stay triggered. If we also open switch 1, the lamp will turn off because there are no current through this circuit. So next, I will explain what if the switch 2 is connected with this circuit. So firstly, if we open all the switch, we can see that the lamp is off. And if we close switch 1 while the other switch is still open, the LED will still off. But if we close SG switch, the lamp will open because the gate leg of the SCR will trigger even though the switch 2 is open. Then, if we open SG switch and close S2 switch, the LED is staying on because the SCR is still in on state where the gate leg is still triggered. And if we open switch SG and switch 2, the lamp will turn off because the gate leg of the SCR is not triggered anymore due to the condition of the SG before this is off. Therefore, the gate leg turned to off condition.
Hi, my name is Inuf Aikah Mekitamin. My matrix number is DE190116 and I will continue to explain about the simulation for activity 2, which is register characteristic. So the first thing that I will do is that I will connect the circuit as shown in the given figure using the multi-sim software, and then the S1 will be closed and I will set the Vout1 to its minimum value, and the readings of the anode current, which is IA, and the voltage across the resistor, which is VAK, are recorded. And so to record the value, I will put the multimeter. I will put 2 multimeters to record the values, and then the SE is closed momentarily, and then the output will be observed. Then the values of IA and also VAK are recorded using both of the multimeters just like before. And lastly, the value of VR1 is increased slowly while IA is observed as it is reduced to determine the holding current which is IH, and at some point the resistor will be turned off. So the IA is the current indicated just prior to turn off occurring. And so I will get the results for IA, which is 756.442 milliampere, while for IH is 21.733 milliampere, and lastly for VAK is 1.065 volt. And then when the switch activity circuit was turned off after it was being triggered, the lamp is still on as the current that flows through the circuit remains at the holding current, and then the results are obtained. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq bin Isa and I'll be presenting for the activity number 3, which is the phase control. Okay, so in this, we have the figure 4.3, which is the ACR power, which switch with the AC input. Okay, so this is the AC input with the voltage of 12 voltage. And then we have the resistor with a value of 470 ohm. And then we have the variable resistor, which has the value of 10 kilo ohm maximum. And here we have the 0.33 microfarad capacitor. And here is the diode, which is connected to the gate of this resistor. And then the emitter is connected to this in series with the lamp, which also act as a load for the circuit. So we have the oscilloscope also connected in parallel with the lamp. Okay, so we need to first construct the circuit as shown in figure 4.3, and then monitor the VS and the VL, observe the effect of varying VR1. After that, common timescale, sketch the waveform VS and VL for the minimum, midpoint, and maximum setting of VR1. Then we have to determine the delay or angle of each cases, write the result in table 4.3. Then finally, we have the varying VR1, estimate the range over which the firing angle can be varied. Okay, so you can go ahead and look at the simulation. This is the circuit has been constructed based on the figure 4.3. So we can go ahead and start the simulation. So here we have the simulation. So we start from the 0. So we can look at the graph. Okay, so when we increase the value of the variable resistor, we can see that the firing angle has been delayed. So we know it's going to the right. Okay, so you can see that the firing angle defines means that it is when the thyristor starts. So we know when it is activated from the gate, so it can allow the current to pass. So until it reaches the point of around 49, it will go to 0. There is no voltage at the load. And then we can go ahead and find the value of the current voltage at each cases of the alpha. Okay, so here we go and open the ammeter and also the voltmeter. Okay, so we can see that at minimum value, the voltage is around 3.317 voltage. Meanwhile, the current is 245 milliampere. And then when we go to the midpoint, around 48, we have the value of the voltage, which is around 773 millivolt. And then we have the current, which is 51 point something milliampere. And then we can go ahead for the maximum angle cases. Then the voltage is around, okay, wait for it to go to the positive side. It is around 157 nanovolt, and then for the current is around 10 nanoampere. Okay, I think that is all for the simulation. And then we can go ahead and check for the range of the alpha. So we see that this is the formula for the alpha variable. So for the alpha number 1, we already calculated based on the result obtained. For the alpha number 3, which is the maximum value, we saw from the graph it is very close to 0, so we will neglect that one. And so we can calculate from the value on the table for the A1 and also the A2. To get the range of the alpha, we can minus the alpha 2 and the alpha 1, and we get a value of 62.61 radian per second. Okay, I think that is all from me. Thank you for watching my part of the presentation.